Hello everyone, welcome to Infotainment Lounge. Today's video is about the electrolysis of aqueous solutions of ionic compounds. Now, while electrolyzing aqueous solutions of ionic compounds, actually we have variety of ions because not only the ionic compound produces its ions, but produces ions from water. Those ions are hydrogen ions and hydroxide ions. So actually, at each electrode we have a choice of ions. At cathode we have a choice of two cations and a choice of two anions for the anode. But the thing is that both the ions are not able to react with the respective electrodes. Only one of them may react with the electrode. Like at cathode, only one cation is going to be discharged, and at the anode only one anion is going to be discharged. Now, which one of them is going to be discharged, that we have to choose according to their reactivities or simply their ease of discharge. For that, you need to learn the series of ease of discharge of cations and anions. So here is the series of ease of discharge of cations and anions. In this series, the ones at the top are the most difficult ones, like potassium and for anions, sulfate. They are the most difficult ions to discharge, and ones at the bottom are the easiest. So among anions, hydroxide ions are the easiest ones to discharge, and among cations, silver ions are the easiest to discharge. Okay, now we have, when we are dealing with aqueous solutions of ionic compounds, we have a competition between two cations. One of them is always hydrogen and the other one could be any of the rest of the ions. And for anions, for anode, we have a competition between hydroxide ions and any of the other anions. So only one of them is going to be discharged. That means we have to choose by using this ease of discharge series. Now we can see that hydroxide ions are right at the bottom of this ease of discharge series. That means they are easiest to discharge. So we could assume that whenever we are electrolyzing an aqueous solution, hydroxide ions are going to be discharged always. But that is not the fact. The outcome may be different if the other ion is present in a high concentration. Due to its high concentration, it may overcome the ease of discharge of hydroxide ions. Same goes for the cations. Some of these ions, if present in high concentration, they may overcome the ease of discharge of hydrogen ions and get discharged themselves. So we have to see if the concentration of the ions is high or not. But today I am not going to go into the factors affecting electrolysis like concentration. I am going to explain you just simple electrolysis of ionic compound, aqueous solutions of ionic compounds with dilute concentrations, not concentrated ones. So let's take an example. So the example is electrolysis of aqueous copper to sulfate. If we have to electrolyze a dilute solution of aqueous copper to sulfate and we are using inert electrodes, keep another thing in mind, that type of electrodes is also another factor which affects the outcome of electrolysis. Reactive electrodes, if we use reactive electrodes, they do change the outcome of electrolysis. So I'm not going into that today. Today, just consider the electrodes to be inert. Suppose they are made up of graphite or platinum. Now, we have all the equipment needed for a basic electrolytic cell. We have a battery here as a source of electric current. We have two electrodes. The one connected to the positive terminal of the battery is the anode, and one connected to the negative terminal of the battery is the cathode. We have the electrolyte. Electrolyte is aqueous copper to sulfate. Now the ions present in copper to sulfate solution are obviously copper 2 ions, sulfate ions. These are the ions which are coming from the ionic compound. But whenever an ionic compound is dissolved in water, although being a covalent compound, it starts ionizing itself. It's called self-ionization. And water, whenever ionized, it produces the same set of ions, H plus ions and OH minus ions, hydrogen ions and hydroxide ions. Okay. We have a choice of two ions, copper 2 ions and hydrogen ions. Only one of these two ions is going to be discharged at the cathode. And from the ease of discharge series, we know that copper 2 ions are below hydrogen. That means they are more likely to be discharged. So instead of hydrogen, copper 2 ions will go and react with the cathode. How are they going to react? They are going to gain electrons. Cathode is going to lose its electrons to copper ions, and those copper ions are going to gain those electrons to become neutral. So copper 2 ions, they gained electrons to become neutral. Now these copper 2 ions were present in their aqueous form because it was an aqueous solution. The neutral copper formed would be a solid and it would be deposited at the cathode. Now at anode, again we have a choice between hydroxide ions and sulfate ions, but only one of them is going to react with the anode. Which one? Hydroxide ions. Why? Because hydroxide ions are below sulfate ions in the ease of discharge series. And whenever hydroxide ions are discharged, the equation at the anode is like this. The state symbols are hydroxide ions, aqueous, water, liquid, oxygen, gas. This is a simple equation of discharge of hydroxide ions at anode. Whenever they are going to be discharged, the equation would be like this. So just learn this equation. This would be used a lot during electrolysis questions. So now we have cathode equation and anode equation. These are called half equations. At cathode, electrons are being gained by copper ions, and gain of electrons is called reduction. So this is the reduction half equation. And at anode, electrons are being lost by the hydroxide ions, and loss of electrons is oxidation. That means hydroxide ions are being oxidized. So this is the oxidation half reaction. But as we all know, electrolysis is a redox reaction, as both reduction and oxidation are taking place. And there is one simple principle of redox reactions, that the number of electrons gained is equal to the total number of electrons lost. It has to be. So if we have to construct an overall equation, we have to first balance out the electrons in both the half equations. How we can do that? We can see 4 electrons at the anode equation and 2 electrons in the cathode equation. So we can simply multiply the whole cathode equation with 2. We cannot just change this 2 to 4, because that way the equation would become unbalanced. So we have to multiply the whole equation with any whole number. After multiplying it with 2, we'll get 2Cu2 plus 4 electrons, and we'll get 2Cu. Now we'll take the anode equation as it is. Now to form the overall equation, we have to add both the half equations after balancing out the electrons. Now as you can see that we have 4 electrons on the reactant side and 4 electrons on the product side, so they would be cancelled out. The remaining reactants are copper ions 2Cu2 plus hydroxide ions, 4OH minus, and on the product side we have 2Cu, 2H2O and O2. This equation is the overall equation, the redox equation for this particular electrolytic cell. Now let's move on to the products. During the electrolysis of aqueous solutions of ionic compounds, we get three different products, one at anode, one at cathode, and the third one is in the solution, like what remained in the solution after electrolysis, after the electrolysis has been complete. So at cathode, we can see the product of cathode equation is solid copper. So copper solid is the cathode product. At anode, products are water and oxygen, but water was already there, so it's not a new thing being formed there. So basically oxygen is the new thing being formed at the anode. So oxygen is the anode product, not water. Oxygen gas is the product. Now in the solution, what remained in the solution, we can see that copper 2 ions were discharged, so hydrogen ions did not take part in the reaction. Similarly, sulfate ions did not take part in the reactions. They are still there in the solution, and they can simply combine with each other to form sulfuric acid. Hydrogen ions and sulfate ions, they form sulfuric acid, H2SO4. So initially the solution contained copper to sulfate and water. Copper to sulfate is a salt and water obviously is a neutral compound, so the solution was neutral. But after electrolysis we'll get an acidic solution as sulfuric acid is being formed in the solution. That is the solution product, and we'll get pure copper and oxygen gas during the process. If we need to collect oxygen gas being produced during the reaction, we may change the apparatus in such a way that we could collect that gas. I'll do a separate video for that. But this is how a typical electrolytic cell containing the aqueous solution of an ionic compound as an electrolyte works. You can try different electrolytes, like different ionic compounds solutions for electrolysis. Keep in mind the main theme is the same. It's not about learning the products of specific electrolytic cells. It's about the technique. You must know the technique. If you know the technique, then there is no limit. They can ask you anything about any electrolytic cell, and if you know the basic skills of electrolysis, you will be able to handle them. If not, if you have learned a few electrolytic cells, that is not the solution. That will not lead you to success. So I hope this video was helpful. Stay tuned for more content ahead. Thank you very much.